Alright, we started on logic and algebraic reasoning yesterday or in our last lesson, and today we're going to look at proofs. This is basically just expanding on what we just did. So a proof is a logical argument that uses deductive reasoning to show that a statement is true. We looked at this and we're looking at two-column proofs today. Okay, so yesterday we looked at this example here where we are to prove that angle DBA is equal to the measure of angle EBC. So we first had that we know that these two angles, M1, measure of angle 1 and measure of angle 3, are the same. That's given. Okay, notice we number these in our two-column proof. Next step, we said that the measure of DBA is the measure of 3 and 2 put together. We know that because of the angle addition postulate. And then thirdly, we know we can substitute in 1 for 3 because we know these two are equal. And then since given the angle addition postulate, EBC is 1 and 2 added together and DBA are 1 and 2 added together, I can substitute, or I can use transitive property saying 1 is 2, 2 is 3, so 1 must be 3. Alright. We have these theorems written down, reflexive, symmetric, and transitive. They work for segment congruence. Segment congruence is reflexive, symmetric, and transitive. That's theorem 2, and theorem 2.1. And theorem 2.2 is angle congruence. Angle congruence is symmetric, reflexive, and transitive. Okay, so all three of those apply to segment congruence as well as angle congruence. So, naming some properties here. Properties of congruence. This first one is, we have angles here. So this is angle congruence. And then which one do we have? T is V, V is T. That's symmetric. Okay. Nope, sorry. T is V, V is R. Correction. 1 is 2, 2 is 3, so 1 must be 3. That's transitive. That's the transitive property. Riding with a mouse here. Transitive property of angle congruence. Angle congruence. We're not going to try that again. There we go. The angle congruence. All right, and then here we have a segment. This one is symmetric. We've flipped it around. That's a symmetric property of segment congruence. All right, a two-column proof. Write a two-column proof for the symmetric property of segment congruence. We are given segment LM is congruent to NP. All right, so that's what we're given here. That's always the first thing we write down. What are we given? Okay, that means, and you have to in a proof write this down, we know that if it's congruent, it is the same length. Why do we know that? Because that's the definition of congruent segments. So if you want to state that they are the same length, then you need to write that they are the same length according to its definition. We know that NP is equal to LM because of the symmetric property of equality, which is what we looked at in the last lesson. Symmetric property of equality says I can write it one way or the other. And so, if they are equal, we know if their measures are equal, then they are congruent. Definition of congruent segments. And there you have it. We have proved segment congruence. All right, writing a two-column proof. Prove this property of midpoints. If you know that M is the midpoint of segment AB, prove that AB is 2 times AM and AM is 1/2 AB. All right, we know that M is the midpoint. That's what we're given. We're proving that AB is 2 times AM and AM is 1/2 AB. Okay, so since M is the midpoint, the definition of midpoint tells me that AM is congruent to MB. And we can state that the measure of AM is equal to the measure of AB. That's the definition of congruent segments. If they're congruent, their measures are equal. Segment addition postulate, remember postulate 1, 2, tells us that if I add these two together, I get the measure of AB. Now I can substitute AM here for MB because in step 3 I showed that they are equal measures. So I can substitute in. And then AM plus AM is 2AM. So I used reverse distributive property here. I factored out a 2 and said 2AM is AB. So I've proven my first point. Next, I can divide by 2 on both sides, and I can prove the second point. Alright, and here's just a quick summary of everything that we've looked at with a 2-column proof. Alright, if I want to prove the symmetric property of angle congruence, okay, I have angle 1 is congruent to angle 2. I want to prove that angle 2 is congruent to angle 1. Okay, sometimes it helps to draw yourself an image. Sometimes it's important that you label them, which one's 1 and which one's 2, if you have to, if it's not given. Okay, we're given this. If you would like to copy this down to your notes, this is a good little quick summary here. And that's all for the 2-column proof.